All right. So this is what this does. So first of all, the magic hexagon, and this is magic. It's pretty cool. You're going to like it. So it's like a power boost for your game. Isn't that cool? It's like a power boost. Probably. Okay. So the first thing that our magic hexagon does is this. If you start at tan, so if you go clockwise around the outside, clockwise around the outside is divide. So tangent equals sine divided by cosine. Tangent equals sine divided by cosine. Sine equals cosine divided by cotangent. Cosine equals cotangent divided by cosecant. Okay? Okay. All the way around the outside. So that's divide. So if you go the other way, it also works. So cosine equals sine divided by tangent. No. Outside is division. Okay? Clockwise and counterclockwise. The first one equals the next one divided by the last one. All the way is division. Okay?
So SBCSC equals SEC divided by 10? Cosecant, you mean? Oh my God. You mean COC divided by COC?
Cosecant equals secant divided by tan. Yes.
And cosecant, does cosecant also equal cotangent divided by cosine?
Yes.
Either way.
So the outsides are divided. All right. So does everybody see that? So the outside is divide, right? We get this? All right. So the next thing that our magic hexagon does is this. On the straight line, so for instance, sine times cosine is 1. Sine times cosine is 1. Secant times cosine is 1. Cotangent times tangent is 1. Right, opposites. Okay? Okay, somebody smarter than me. Okay. No, I did not do this. I'm positive. Yeah, and it took me a minute to actually think it through. Okay. So coming in, multiplying is 1. Okay? So the next thing we can do No. So the next thing we can do is we are playing a game and we're learning about our power boost and we're having fun. There will be no naps. So, okay, so we're still multiplying, okay? So on the lines is multiplying. So tangent times cosine is going to be sine. So the two outsides when they come together, when you multiply. So cotangent times sine is cosine. Okay, so watch. I'm going to do the one. So tangent times cosine is sine. Sine times cotangent is cosine. Okay, can we just, we did the, when you multiply, yes. Correct. Say that again. Cotangent. When you're multiplying. We're multiplying.
Yeah, cosecant and cos.
Go back to the first one. Like I said, cosecant is equal to secant divided by tangent. It's the same if I go like the other way.
Wait, say that again, baby.
Cosecant is equal to secant divided by tangent.
Because that's on the outside, right?
And then if we go backwards, cosecant is equal to cotangent divided by cosine.
Mm-hmm. So it's division on the outside. When they come together, that's multiply. It's multiply when they come together. So sine times cotangent is cosine. When they come together, it's multiply. Around the outside is divide. Probably not. Okay. But I'm thinking maybe if you learn how to use this, I'll let you use this with nothing written on it. But this will have all, this is all the information. All right. So, okay. So here's another one. So watch. If I go straight across. So when they came together, you were multiplying, right? When these came together, you're multiplying. When you go around the outside, you're dividing. If you go straight across, sine equals 1 over cosine, or cosecant. Cosine is 1 over secant. Cotangent is 1 over tangent. Okay? So it gives you all the reciprocals.
Okay, so and then, but then cos divided by secant equals 1, right? That was the big one.
Which one? Cosine.
Yes, you said earlier. You said the two outsides, like parallel to each other, like if they divide by each other, equal 1.
I said multiply.
Those are multiply?
Coming together is multiply.
Outside of division.
Yes.
But if they come together on the outside,
It's to multiply.
Wait, what?
Okay. Shh. Okay, that's why y'all have notes, and you can study the little pictures if you're not following now, okay? Okay. Back to the Pythagorean identities. So the ones you colored in, okay, the 3 that you colored in, okay, you have to go across the top on the colored ones. Tangent squared plus 1 is secant squared. Sine squared plus cosine squared is 1. 1 plus cotangent squared is cosecant squared. So you have to go across, and it gives you all the identities. Okay?
So when you divide, you go all the way around, you put 7 next to it, and you multiply.
Going in. And the colored ones, you go across, and it gives you the identities. Okay? So, right here are all the instructions on the magic hexagon you will ever need. Okay? But don't lose this, because this is what I think you're going to get to use on your test. All right? I'm not positive, but I think yes.
Why are you not positive?
Well, I have to make sure what Miss Rice is going to do. All right.
Just don't let her know.
No, because you guys can't keep your mouth shut. No. Mm-mm. Nope. You have friends in there, and you will tell, and you'll be like, ha ha, we get to use this and you don't. Mm-mm. Not doing that. You are. Mm-hmm. Okay. All right, so everybody, I'm going to do some more on the notes.
What if like you see me like low-key use it, but no one else uses it? You like hint on something?
Of course I'm going to tell you. Oh, my gosh. All right.
Why am I drawing?
It's your power boost. You don't want to throw it away. All right. All right, so I'm going to run through real quick. This is very quick. I'm going to go through, what? Yes. So I'm going to run through some of this. Okay, not yet. All right. So when I'm doing a problem, one of the things I look at is, would it be easiest to get them all in terms of sine and cosine? So for instance, if I have sine and cotangent, cotangent is going to equal what? Well,
Cotangent equals
It'll equal cosine.
divided by sine.
okay, thanks. So what happens with the sines? They cancel, and I have cosine, and I win. 1 minus sine squared, what does that equal?
So it equal 1.
Yep. What's 1 over secant?
1 over secant?
just,
Cosine. You have to get the x.
So if I have cosine of x, tangent is sine over cosine. So what's secant? So these cancel and you get 1. Cosecant, 1 over sine. So if it's 1 over sine, what happens when it flips and leaves you with sine squared?
Whenever I look at like the work I do, like it makes me so smart.
Yeah, because you are.
No, but I'm saying like because like that's crazy. Like,
Look how smart you guys are for doing this. You're winning the game. All right. On the next example. So when you get something that looks like this, we're not going to cry, but it's not over a common denominator, correct? So the denominator is cosine of x. So I'm going to multiply this times cosine of x over cosine of x. So my common denominator is now cosine of x. So I have sine squared of x plus cosine squared of x.
How do you get the square on the cosine?
Cosine times cosine.
You just added a cosine on its own?
No, because you gotta get the common denominator.
I said you have to get a common denominator, and Bruno, you're the one who said yeah.
Also, you just threw away the plus sign, or what's up?
I didn't throw anything away, Bruno. And plus, what's up? It's still here.
Okay.
He's just so genuine about it.
I don't know, but he was the one going, yeah, yeah. So,
I didn't know you had the cosine x.
okay,
Cosine x.
this is over cosine, right? So I need this one to be over a cosine. So I put it over a cosine. But to do that, I multiply by cosine over cosine because it's like multiplying by 1. And that doesn't change anything. So now I have cosine squared and the sine squared, and now they're both over a cosine. So, okay, so that's a common mistake. We can't cancel out one of the cosines, okay? Because there's not a cosine here. But what I can do is sine squared plus cosine squared. 1.
She looks so concerned.
And 1 over cosine of x.
Oh my goodness.
Won the game. The game does not suck. You are having fun. I don't know how many times I have to tell you, but you are. Okay, can we just finish the notes? All right, so I have sine over tangent. So, how did you get that, Angie?
I looked at my octagon.
Oh, you looked on the octagon, okay. The hexagon, darling, hexagon.
Yeah, she be adding this on, bro.
I know. Do you know something I don't? You learned the magic octagon? Okay. Okay. Yeah. Come back to our level, Angie. Don't jump ahead of me, okay? All right. So I have sine. We can do it on the hexagon. Thank you. I'm like, what is it again? Which one was it? We could do sine of x over sine over cosine. And so what happens when I flip? And you're left with, what did you get, Angie? I got cosine.
I don't know. Yeah, this is secant.
Oh, she's going the opposite way, not that way.
Opposite, yeah.
I'm confused.
All right. Well, I'll be there to straighten you out. Bring you back to my level in just a second.
Okay.
All right. So, all right. So here's where you can cancel, though, Isaac. I have sine squared over sine. And that's all that's there, right? There's 2 signs on top, 1 on bottom. It's okay to cancel there, and you get sine of x.
Oh, I did the wrong thing. Never mind. You're right.
I'm okay?
I read it wrong.
Phew. All right.
Sine
Sine squared of x. And what is sine squared of x minus 1? So I have sine squared of x plus cosine squared of x equals 1. So it's a negative cosine squared of x.
Wait, Miss, where did the cos come from?
It's the formulas, dude. Like, it's the formula.
That thing she just wrote, the sine plus cos, the cosine, that's just the formula.
Yeah, that's not the answer.
That's not what you, like, that's not a part of it.
This is the answer. I'm just using this identity to substitute in here. Okay, so the next one. So I think these are the ones you all are like, this is hard, all right? But if you look at this, what's in both of these terms? Sine. And what's the smallest exponent in both terms? 2. So that's a greatest common factor. So I'm going to have sine squared of x times sine squared of x plus cosine squared of x. And now sine squared plus cosine squared is 1, and all I'm left with is I know. So I have 1 minus cosine squared of x. So if I look back at this, 1 minus cosine squared is going to leave me with positive sine squared. Okay, on your yellow worksheet, I'm going to work one with you. Oh, sorry. How about 1? Are you good, Andrew?
Yes.
All right, here we go.
Is this free and free?
No. I know what it says. I'm giving you premium points for it, okay?
Giving us extra credit?
Holy crap, this is pretty.
Hey, now, Simon.
I thought we were using pre-cal.
I know.
You get premium points for this one? Oh.
Oh my god, look at number 6.
Yeah. All right.
Wait, that all cancels out, though.
Okay, it is all going to cancel out. That's exactly what's going to happen. All right. So, okay. So, first of all, the reason I'm doing it is because you look at it and you're like, oh my gosh, this looks so hard. And then you say, I don't know where to start. That's your next question, okay? So I was telling my last class, you know, it's not like I have these memorized. Like I look at this and go, the answer is cosine. I don't. So this is what I do look at, though, when I'm looking at it. So I know when I'm doing this, I want as much to cancel out as possible. So when I look at this, I have secant and tangent here, right? But what's down here? But they're not common denominators. But if they were, what happens when you invert that? And the secant and tangents will cancel out. Okay? All right, Bruno, pay attention because I'm going to put this over a common denominator on the bottom. Are you ready? Okay. Most of the time, if it's like secant and tangent, sometimes if you switch it all to cosine and sine, then that helps. But I just know by looking at this, I know if I put these over a common denominator, they'll cancel. Okay? So I'm just going to write the bottom so you can see me do this because you're going to probably have to do this on another one. So the first thing I know is I'm going to put it, I want my common denominator to be secant and tangent. So this one has tangent, so it's missing what? Secant. So I'm going to multiply the first term by secant over secant. Does that make sense? Okay. So I get secant squared. And then the next one, I have to multiply by tangent over tangent. So I get tangent squared of x over tangent x secant x. Right? Yes, because now they're both over the same thing. So now this is what the bottom looks like. So next thing I'm looking at really quick here is secant squared minus tangent squared. I don't have the identities memorized, but I know probably that is an identity somehow. So if you look at your identities, the secant and the tangent go together.
1 plus tangent squared equals secant squared.
1 plus tangent squared equals secant squared.
Yes.
So I have secant minus tangent squared. And what does that equal?
1.
So this is 1 over tangent secant. So on top, I have 1 over So what happens when I flip those?
It's 1.
And it becomes?
I could've. That's what I got.
So if I
Mine
just
did
guess
something so
and I
different
put
from me.
1 or
And I screwed up one.
Okay, that's what Jada's going to do. She's going to write the answer to 1 for everything. And she thinks she's going to get enough right, she'll pass. I don't know. We'll see. If you have to guess, I guess 1 is probably a good guess. Okay, we're just doing the evens.